Hi everyone, and welcome to part 7 of the DMC2 training series. In the last two videos, I set up a bunch of different cam operations on a test part to cut, and then loaded the raw stock material to cut in the DMC2, which was set up in the cam files earlier. From there, the 6mm end mill for the first operation was loaded, and the part was probed into place. The last step to do is to load the file and click Cycle Start. To load a file in Mach 3, you simply click the Open File button and click on your selected G-code file. It will take a few seconds to load and you'll see the toolpath shown in the window to the right. Before we actually click Start, there are a few things to check. First of all, make sure that you have coolant if you're machining something that will require it. Machining metals at high speed without coolant is a sure way to burn your end mills very fast. If you forgot to enable coolant in G-code, you can always override the pump and turn it on with the green coolant button at the front, or in Mach 3 by clicking coolant, and alternatively you can turn it off in Mach 3 if it's turned on in G-code. The green button does not turn off the coolant if it's already enabled in G-code, so be careful not to cause a mess if you start a file with the cover off. When everything is ready, make sure that the tip of the end mill is above the top of your part. Put the cover securely on the machine and then click Start. The machine will begin the job and you'll see the G-code being streamed to the controller as it runs. As soon as the job starts, be close to your EStop button and watch that the first thing that the machine does is what it's supposed to do from the cam simulation. In this situation, I'm looking out for the beginning of the facing operation at the front side of the stock. It looks good here, but if the machine does anything else other than what you were expecting or goes off in a direction away from the part, immediately hit the red EStop because you've probably made an error probing or loaded the wrong file. Whenever you hit the EStop, you should rehome the machine and reload the G-code file you intend to run, and then reprobe the part. With closed-loop motors, generally EStopping does not lose the machine position, but sometimes a small slip can occur while the inertia of the axes are still going, but the controller demands an abrupt stop. Keep in mind also that when you load a G-code file, the toolpath should show up in your controller software, so you can immediately tell if the file looks completely wrong. So watch the job for the first bit, and make sure that the spindle does not sound like it's excessively bogging down. Also, listen to the sound of the cut, and make sure that it's not gradually getting heavier, or that the pitch of the spindle sound is changing. That's a sign that something will quickly go wrong, like a dull end mill rapidly getting hot and wearing out. On the Mach 3 screen, you can click the override button to either increase the speed of everything or decrease it. This is a quick cheat to slowing down anything on the fly, rather than going back and editing the G-code. Just remember to reset it back to the default speed when you're done. Recall that adjusting the spindle speed affects the surface speed and changes the chip thickness. Adjusting the feed rate adjusts the chip thickness and overall load on the spindle only. When you adjust one by a large amount, it's a good idea to adjust the other at the same time at a similar rate to keep a consistent chip thickness, but change the overall cutting loads on the spindle. If things sound bad and you decrease the spindle speed alone, then you just made it even more difficult for the spindle to cut and more likely to stall. So if everything in the cut seems well, then you can leave the machine to work on its own. It does have EStops on each axis if it detects a stall, but if that happens, chances are there were already ample warnings and you may have already damaged your end mill or parts. If all goes well, the machine will complete the entire job and then return to its start position and power the spindle off. In my case, I've set the machine to go to a certain position after each job that brings the bed forward and puts the gantry off to the left. If you're doing this, you don't want the bed to park all the way forward because all the chips from the previous job could pile up in the rail covers and then get crunched when the bed is pushed to the far end, resulting in stalling the bed in extreme situations. At this point, the first operation is done. But since we need to do multiple operations, we're going to leave the part clamped in the vise, retract the Z up to a safe location above the part, and then swap the tool out for the next tool that we need, which in this case is a 4mm flat end mill. Notice that if nothing went wrong and the axes did not crash or anything, then the tool center line is still probed to the X and Y coordinates, so we don't need to reprobe those if they were set up the same throughout the different setups in CAM, which is a good way of saving time. We do need to probe the Z height of the new tool, however. When the tool is installed, we can lift the Z up above the part and jog over. Insert the height puck, and then zero the Z axis again as usual. But there is a problem here. Notice that this top surface is not the same surface as the original stock, since it was all machined down a very small amount. That means that our work coordinates in CAM are currently wrong, and running it how it is would result in everything cutting deeper down than we want. You need to be careful of these little details anytime you choose a surface to probe off of. So we need to go back in the second setup for this tool and change the work coordinates to still be over the same x and y coordinate, but on the new top surface of something real that we can probe, which is just the top of the new faced surface. Also, thinking ahead now, I know I'll use the top features to place the height puck on top of to probe for each other tool as we continue, so I'll change that now for the other setups as well. Also, a good practice is to rename your setups to something that makes more sense to you, so you don't accidentally post the wrong one, or come back to the file later and be confused what's what. After modifying that, we can post the setup for the correct 4mm tool now, and then save it to the machine folder as usual. On the machine, the x and y coordinates are still correct, and to update the z position, we insert the height puck, click Auto Tool 0, and we're ready to start the job. Same thing as before, click Cycle Start, and watch to make sure it begins running correctly. Everything looks good here, so I'll leave it to run on its own. Now that that's done, following the same procedure, I can swap out to the 4mm ball end mill and post the correct file, load the file on the machine, and reprobe the Z height to run the job. So the ball end mill operation is now done, and now I have just one more tool to load in for the final operation, which is my 6mm chamfer mill. Since this tool is a 6mm shank, I need to swap out to a 6mm collet. Note that you should always use a collet that is rated for its maximum holding size. So for this 6mm end mill, I want to use a 5 to 6mm collet, and not a 6 to 7mm or 1/4 inch. They would work fine, but for the best results, always use the maximum so that the spring doesn't even need to compress. Everything looks good, so this entire job has been successful. That concludes everything you need to get yourself up and running with the DMC2. There are endless more features in Fusion 360 and things you can optimize and tweak for your specific setups, so I encourage you to explore other learning resources for more advanced cam tips, and just play around in Fusion and see what pops out in the simulation as you change parameters. In the next video in this series, I'm going to walk through the process of calibrating your probe to your machine. Calibrating is something you need to do only once when you initially set up your machine, so if you're following along with your CNC, don't actually attempt using the probes yet until you watch the next episode. So thanks for watching, and I'll see you in the next one.